We start off with our third class on integration, and this class is going to be one of the shortest class that we have done. And today we are going to discuss a very simple topic. Well, it is not much to do with integration all by itself, but it has got a lot to do with trigonometry. So we are going to make use of trigonometric identities and all the formulas that we have learned in class 11. We are going to just make use of those formulas and we are going to try solve the integration. So basically what we need to do is, whatever the integration that is given, we have to try and converting that given function into a form which is integrable. So the function which is given at the beginning may not be in the integrable form, so we have to just use the identities to bring it down, boil it down into an integrable form, and then we have to integrate. So in that case, we don't have much to introduce here, so let us go directly into the problems and solve. So let us take the first example. The first example is integration sine 4x cos 3x dx. So a very simple integration as it looks. So what given is, we don't know how to integrate when two trigonometric functions are in the multiplied form. So we know that using transformation formula we can convert the product of trigonometric function into sum or difference. So let us do that. So what to do for that? We need to multiply a half and a 2. So 2 sine 4x into cos 3x, that is in the form 2 twice of sine a cos b. So let us, what is the formula for twice of sine a cos b? That is sine of a plus b in plus sine of a minus b. So if you have forgotten, please ensure you open your class 11 book and go through all the formulas. So basically what you are given is twice of sine of a plus twice of sine of a cos of b, and that is equals to sine a plus b plus cos of, once again, sine of a minus b. So that's basically the formula. So that's exactly what we are going to apply. So let us do that. So if we do so, what do we get? We get something like this. So sine of a plus b, that is 4x plus 3x, that is 7x, and a minus b, that is 4x minus 3x, that is x. So now the integration is in the function is in integrable form. So let us do the integration directly. So sine 7x integration is minus cos 7x by 7, and sine x integration is minus cos x. So therefore your answer is this: minus cos 7x by 14 minus cos x by 2 plus c. Let us take the second problem. The second problem is basically integration sine to the power 4x dx. Now sine to the power 4. Now how to deal with sine to the power 4? So let us see. So let us take sine to the power 4x dx, which can be written as sine square x whole square, obviously. Now sine square x, the nearest formula that we know for sine square x, that is we know twice of sine square x, that can be written as 1 minus cos 2x. This is a formula which we already know. So we are going to try applying that formula here. So let us multiply a 2 inside. So now 2 multiplied inside the square, that means I have to multiply divide by 4 outside. So therefore 1 by 4 is outside the integration and 2 is multiplied inside the integration inside the square. So 2 sine square x, that can be written as your 1 minus cos 2x, and then again I have a whole square, so let me square it out. So if I square it out, I have 1 minus 2 cos 2x plus cos square 2x. Then again cos square 2x. So cos square 2x can be written as, if you remember once again, 2 cos square x, that can be written as 1 plus cos 2x. So therefore 2 cos square 2x becomes 1 plus cos 4x. So accordingly the formula will change. So therefore if I try applying that, which we have done here in the next step, what we have done, we have separated out 1 minus 2 cos 2x because it is already in the integrable form, and cos square 2x I have multiplied a 2 and therefore I have to divide it by 2, and there was 1 by 4 already outside, so there it becomes 1 by 8. So now 2 cos square 2x can be written as 1 minus cos 4x. So now we have separated out all the integrations and we are doing the integration individually. So therefore it becomes x by 4 minus sine 2x by 8 plus x by 8 and minus sine 4x by 32. So now once again if I just rearrange everything, so I have 3x by 8, which we get by adding x by 4 and x by 8, and then uh, minus sine 2x by 8 and minus sine 4x by 32. Fine. So that's it. That is the integration. So you can see that integrations are not difficult. It's just that we need to apply the trigonometric identities to convert the integration into a integrable form. Fine. So here this type of integration is all about trigonometry. So here integration is not much important. The trigonometry is. Next, number 3. Number 3 is, so here also evaluate integration of sine x dx by sine of x minus alpha. So we are going to try applying some trick here to do so. What is the trick? We add an alpha and subtract an alpha inside sine. So when we are adding and subtracting an alpha, we can consider this whole thing, we can consider this whole x minus alpha as one thing and alpha as the another thing. So therefore we are going to apply the formula of sine of a plus b. So if you have forgotten the formula of sine of a plus b, so sine of a plus b, that is equals to sine a cos b plus cos a sin b. So basically this is what we are going to do. So let us apply it. So if we apply it, this is what you get: sine of x minus alpha into cos alpha plus cos of x minus alpha into sin alpha. Now let us divide. If we divide, sine x minus alpha gets cancelled, so we are left with cos alpha on one side. On the other side I have cot of x minus alpha into sin alpha. So this is what we have. Oh shoot, I have done a small mistake here. It should be cot here. It should not be tan, it should be cot. So this is cot. Please correct the mistake. This should be cot. I just mistyped it. So now once I have this cot x minus alpha, so now what we can do, we can just break it down. So if I break it down, it will be cos alpha dx and sin alpha into this should be cot. Once again, please ensure to correct it. Then cos alpha dx plus sin alpha into integration cot of x minus alpha dx. So therefore once we do the integration, we have x cos alpha into sin alpha log of, again this should be sin of x minus alpha, because integration of cot of x minus alpha is log of mod of sin x. So it becomes log of mod of sin of x minus alpha. So please do those necessary changes. I have done this small mistake here. Doesn't matter. Once you have noticed it, I hope you understand. Fine. So therefore, this is the integration. Now, let us move to the next problem. Problem number 4. Okay, so the integration is dx by sine x into cos cube x. I think due to lack of space, the integration, the whole thing looks a little bit small. I hope you can see it. Let me just zoom it out. So this is exactly what the integration is, dx by sine x into cos cube x. Fine. So now let us move to the solution. So first, what we will do, there we have cos cube x, so I will take out one cos square and take it in the numerator, and it becomes sec square x. Fine. Now sin x cos x, I can write this as sin 2x, multiplying 2 in the denominator and multiplying 2 in the numerator. Then sin 2x can be written as 2 tan x by 1 plus tan square x. Now that is an identity, if you remember. Then sec square x is as it is in the numerator. Now let us do a small substitution. What is the substitution? Let us consider tan x as z. Then what happens? Sec square x dx becomes dz. So we apply that substitution in the integration. So this is what we have. So 2 is outside, integration dz by 2z by 1 plus z square. Now take it in the numerator. So 1 plus z square goes up. So 1 plus z square by z dz. If you break it down, I have 1 by z plus z dz. And now it can be integrated easily. So 1 by z integration is log z, and z integration is z square by 2 plus c. But what was z basically? Z was basically tan x. So it becomes log of tan x plus tan square x by 2 plus c. So all you see is basically the tricks here lie mainly in the trigonometry, not in the integration. Right? Next, number 5, and this is the last problem that we have. Integration dx by, let me zoom it out once again, integration dx by sine of x minus alpha into cos of x minus beta, which is pretty much the same as the third problem that we did, but a little bit elaborate. So let us do it. So let us take the first step. The first step is to multiply. Let me zoom in once again. So the first step is to multiply cos of alpha minus beta in the numerator and the denominator. So this is a trick that we have to apply. And then next trick is to write this alpha minus beta in an order, in a fashion. What is the fashion that we have to write? See it here. This is how we can write it. So we can write alpha minus beta as x minus beta minus x minus alpha. So we are intentionally adding one x and subtracting one x. Fine. So now cos of x minus beta minus x minus alpha, once again, if you see this x minus beta to be considered as a and x minus alpha to be considered as b, then cos of a minus b, cos of a minus b, that can be written as cos a cos b minus, plus sin a sin b. So this is basically the formula that which we are going to make use of. So let us do it. So in the next step, this is what we have: cos a cos b plus sin a sin b. Right? Now you can see, you can cancel out the numerator and the denominator, and we have something here. So what we have? So cos of x minus alpha divided by sine of x minus alpha, that is cot of x minus alpha, and sine of x minus beta divided by cos of x minus beta, that is tan of x minus beta. Fine. So now the integration becomes simple, because cot integration we know, tan integration we know, so we will be just directly integrating it. So 1 by cos of alpha minus beta, that remains as it is, and cot of x minus alpha integration is log of mod of sine of x minus alpha, and tan of x minus beta integration is log of mod of sec of x minus beta. Now a little bit of manipulation to get the desired form of the answer. So log of m plus log of n, that makes it log of mn, and sec can be written in the denominator, so that becomes log of sine of x minus alpha by cos of x minus beta. So obviously the last step is quite unnecessary. You can leave your answer at the second last step as well. That will also give you some good marks, if not the full marks, but definitely not wrong at all. So this is your this is the class more or less. So whenever you are solving problems like this where you have trigonometry involved, so please ensure you have to be careful of what formula you are using and all those small tricks that will help you to make the problem easier. So thank you.